I need to tell you something that changed the way I think about reality. And I am not being dramatic. This genuinely rewired how I understand the universe. You are a time traveler, right now. Not metaphorically, not poetically, literally. You are traveling through time at a rate that is measurably different from someone standing on a different floor of your building. The person on the ground floor of a skyscraper ages slightly slower than the person on the top floor. The difference is about 10 nanoseconds per year per 30 meters of elevation. That is real. That is measured. That is not a thought experiment from a physics textbook. That is what your GPS satellite has to correct for every single second, or your navigation would drift by 11 kilometers per day. I want to sit with that for a moment, because I think most people hear time travel and immediately picture a machine with blinking lights and a lever you pull. They picture science fiction, and I understand why. The phrase has been colonized by Hollywood to the point where it sounds fundamentally unserious. But here is the thing that broke my brain when I first understood it. The science fiction version, going backward in time, visiting the dinosaurs, killing your grandfather, that part might be impossible. But the other direction, going forward, skipping into the future while everyone else ages normally, that is not only possible, it is happening to you right now. And the only question is how far you can push it. Let me be precise about what I mean. In 1905, a 26-year-old patent clerk in Bern, Switzerland, published a paper that would eventually destroy the common understanding of time. Albert Einstein's special theory of relativity made one claim that seemed absurd then and still seems absurd now. Time is not universal. Two clocks moving at different speeds will tick at different rates. Not because the clocks are broken, not because of some measurement error, because time itself, the actual passage of moments, the aging of cells, the ticking of every possible clock, including the atoms in your body, runs at different speeds depending on how fast you are moving. This is called time dilation, and I want to be clear that this is not a theory waiting for confirmation. This was confirmed in 1971 when Joseph Hafele and Richard Keating put cesium atomic clocks on commercial airliners, flew them around the world, and compared them to identical clocks on the ground. The airborne clocks disagreed with the ground clocks by exactly the amount Einstein predicted, 50 nanoseconds, not approximately, exactly. I remember the first time I truly absorbed what this means. Not the math, anyone can follow the math. I mean the implication. If you fly on an airplane for 10 hours, you arrive having aged slightly less than someone who stayed on the ground. You have traveled into the future by nanoseconds, but nanoseconds are not nothing. They are real intervals of time that you skipped. The question is not whether you can time travel. The question is whether you can scale it up. And the answer is yes, dramatically. The International Space Station orbits Earth at about 28,000 kilometers per hour. At that speed, time dilation becomes measurable with ordinary atomic clocks. Astronaut Sergei Krikalev has spent more cumulative time in space than almost any human, about 803 days. Because of his velocity, he has aged approximately 0.02 seconds less than he would have on Earth. He is 20 milliseconds in the future relative to the rest of us. That is the current human record for time travel. 20 milliseconds does not sound like much, and honestly, on a human scale, it is not, but the principle has no upper limit. The faster you go, the more time you skip. And it is not just astronauts. At CERN, the Large Hadron Collider accelerates protons to 99.9999% the speed of light. At that velocity, the protons experience time at roughly 7,000 times slower than a stationary observer. From the proton's perspective, if a proton could have a perspective, a single second of its time corresponds to nearly 2 hours in the laboratory. The proton is time traveling, right now, under Switzerland, in a machine built by humans. The future is not something we are waiting for. It is something we are already engineering our way into. The question is whether we can ever scale this up to human beings. And the engineering obstacles are staggering. To accelerate a spacecraft to even 10% the speed of light would require more energy than the entire world currently produces in a year. To reach 99% would require thousands of times more than that. The fuel problem alone seems insurmountable with chemical rockets. You would need to carry so much fuel that the mass of the fuel itself becomes the dominant problem, requiring more fuel to accelerate the fuel, in a vicious cycle that rocket engineers call the tyranny of the rocket equation. But there are theoretical alternatives. Laser-propelled light sails, like the ones proposed by Breakthrough Starshot, could potentially reach 20% the speed of light using ground-based laser arrays. Nuclear pulse propulsion, detonating nuclear bombs behind a spacecraft and riding the shock waves, was seriously studied in Project Orion in the 1960s and could theoretically reach 5 to 10% of light speed. And more speculative concepts like antimatter engines or fusion drives could push even higher. None of these exist yet, but none of them violate physics. The gap between theoretical possibility and practical engineering is wide, but it is a gap, not a wall. I think the distinction matters. When someone says time travel is impossible, they are confusing "we cannot do it yet" with "the universe forbids it." The universe does not forbid forward time travel, it guarantees it. At 50% the speed of light, you experience time at about 87% the rate of a stationary observer. At 90% the speed of light, you experience roughly 44%. At 99%, about 14%, and at 99.99% the speed of light, you experience roughly 1.4% of the time that passes for everyone else. Let me translate that. If you could build a ship that travels at 99.99% the speed of light and fly it for what feels like 1 year to you, roughly 70 years would pass on Earth. You would return to find everyone you knew dead or elderly. Your children would be older than you. Your world would be unrecognizable, and from your perspective, only 12 months would have passed. That is not science fiction. That is special relativity. It is tested, it is confirmed, it is as established as gravity. And I have a confession to make. This scares me more than black holes, more than the heat death of the universe, more than any other physics topic I have researched, because it means the people you love are not living in the same time as you, not exactly. Right now, as you watch this, the clock in your phone and the clock in a GPS satellite 20,000 kilometers above you are ticking at different rates. You and the person sitting next to you, if one of you is slightly higher than the other, are aging at measurably different rates. Time is personal, and I find that profoundly lonely. I sometimes think about what this means for something as simple as a phone call. When you talk to someone on the other side of the planet, your gravitational environments are slightly different. Different altitudes, different latitudes, different distances from Earth's center. Your clocks are not synchronized. The conversation is happening in two slightly different time streams, stitched together by electronics. The disagreement is far too small to notice, but it is there, and it is not a glitch. It is the geometry of the universe asserting itself in the most intimate human interaction. But velocity is only half the story. Einstein published a second theory in 1915, general relativity, and this one was even stranger. Not only does speed affect time, gravity does too. The stronger the gravitational field, the slower time passes. This is not a different phenomenon from velocity-based time dilation. They are both consequences of the geometry of space-time. But the implications are distinct and in some ways more extreme. A clock on the surface of the Sun ticks about 67 parts per billion slower than a clock floating in empty space. A clock on the surface of a neutron star, where gravity is about 200 billion times stronger than on Earth, ticks roughly 30% slower. And a clock approaching the event horizon of a black hole effectively stops. From the perspective of a distant observer, time at the horizon stretches to infinity. I covered black holes in a previous video in this series, so I will not repeat that science here. But I want to add something I did not say in that video, because it did not fit the structure then, and it fits now. A black hole is, in a very real sense, the most powerful time machine that exists in nature. If you could park a spacecraft in a stable orbit just outside the event horizon of a supermassive black hole, not falling in, just hovering, and stay there for what feels like a few hours, thousands of years could pass in the outside universe. You would emerge into the deep future. The stars you knew would have moved, civilizations would have risen and fallen, and you would not have aged a day. The physicist Kip Thorne calculated that for a black hole like the one in the film Interstellar, roughly 100 million solar masses spinning at 99.8% of its maximum rate, 1 hour in orbit near the horizon corresponds to roughly 7 years on Earth. That specific number was invented for a movie, but the physics it is based on is exact. The ratio can be much more extreme for different black hole parameters. And here is where I want to challenge something that I think even most physics enthusiasts get wrong. People talk about this as if it is slowing down time. It is not. From your perspective near the black hole, time passes normally. You are not in slow motion. You do not feel anything unusual. It is everyone else who is in fast forward. The experience of time is always local. There is no universal clock against which your clock is running slow. There is only your clock and their clock, and they disagree, and neither is wrong. This is not a trick of perception. It is the structure of reality. I have to be honest about something. Every time I explain this, I feel the inadequacy of language. English, probably every human language, was built to describe a world where time is the same for everyone. We have no intuitive vocabulary for a reality where it is not. When I say 1 hour near the black hole equals 7 years on Earth, I am using words that imply a universal time standard that does not exist. The sentence is useful, but it is also subtly misleading. The truth is that there is no fact about how much time really passed. There are only two different experiences of duration, and physics gives us the math to compare them, but no authority to say which one is correct. I find that beautiful. Terrifying, but beautiful. Now, everything I have described so far is forward time travel, moving into the future faster than the normal rate. This is real, confirmed, and limited only by engineering, by how fast we can make a spacecraft go, or how close we can get to a black hole. But the question everyone actually wants to ask is, can you go backward? And I wish I had a clean answer. I do not. The honest answer is, probably not, but we cannot prove it, and several solutions to Einstein's own equations seem to allow it, and that keeps physicists up at night. Let me explain. In 1949, the mathematician Kurt Gödel, the same Gödel who broke mathematics with his incompleteness theorems, found a solution to Einstein's field equations that contained closed time-like curves. That is the technical term for paths through spacetime that loop back to their own starting point. In plain language, time loops. Paths where you move continuously forward through time and end up in your own past. Gödel's solution described a rotating universe, which our universe does not appear to be, so the specific solution is not physically relevant. But the fact that Einstein's equations allow it at all is deeply disturbing. If the laws of physics permit something in principle, physicists want to know why it does not happen in practice. Since Gödel, other solutions have been found. Frank Tipler showed in 1974 that an infinitely long rotating cylinder of extremely dense matter could produce closed time-like curves. Richard Bott showed in 1991 that two cosmic strings passing each other at high speed could create a similar effect. And Kip Thorne showed in 1988 that a traversable wormhole, a shortcut through spacetime, could theoretically be used as a time machine if one mouth of the wormhole were subjected to time dilation and then brought back. Each of these requires conditions that are either physically impossible with current technology or that may not exist in our universe at all. Infinitely long cylinders do not exist. Cosmic strings may not exist. Traversable wormholes would require exotic matter with negative energy density to keep them open, and while quantum field theory allows negative energy densities in small amounts, the Casimir effect demonstrates this. The quantities needed for a wormhole are astronomical and may be fundamentally unavailable. And there is a deeper problem. Stephen Hawking proposed what he called the chronology protection conjecture in 1992, that the laws of physics conspire to prevent backward time travel. He could not prove it. That was the point. It was a conjecture, not a theorem. But he pointed to several mechanisms by which the universe might enforce it. Quantum effects near a time machine might produce infinite energy densities that destroy the machine before it can be used. The vacuum itself might become unstable. I want to be transparent about my own bias here. I think Hawking was probably right, not because I have evidence he was, I do not, and neither does anyone else, but because the alternative is so logically catastrophic that I find it easier to believe the universe forbids it. If backward time travel is possible, then causality, the principle that causes precede effects, becomes optional. And causality is not just a physics principle, it is the foundation of logic itself. If effects can precede causes, then what does because mean? What does explanation mean? What does science itself mean? The grandfather paradox is the famous version of this problem. If you go back in time and prevent your grandfather from meeting your grandmother, you are never born, so you never go back in time, so your grandfather does meet your grandmother, so you are born, so you do go back. The loop never resolves. Some physicists have proposed solutions. The Novikov self-consistency principle says that any time loop must be self-consistent, meaning you can travel to the past, but you cannot change it in a way that creates a paradox. Others have proposed the many worlds interpretation. Going back creates a new branch of reality, so you do not create a paradox because you are in a different timeline. I find both of these solutions elegant and both of them suspicious. The self-consistency principle amounts to saying the universe has a narrative editor who ensures plot holes do not occur. The many-world solution preserves logic but abandons the very thing that makes backward time travel interesting, the ability to change your own history. If going back creates a new branch, you have not changed your past, you have just visited someone else's present. That is tourism, not time travel. But I want to end this section by being fair. My discomfort with backward time travel is philosophical, not scientific. Physics does not share my squeamishness. The equations allow it, the universe may or may not. And the gap between those two statements is where some of the most fascinating and frustrating research in theoretical physics lives. Let me bring this back to something concrete, because I started this video by saying you are already a time traveler, and I want to make sure that does not sound like a gimmick. It is not. Every commercial flight you take is a time travel event. Every satellite in orbit is a time machine. The atomic clocks in GPS satellites are deliberately pre-adjusted to tick at a different rate before launch, because engineers know that the combination of velocity-based and gravity-based time dilation will cause them to drift. Without this correction, GPS would accumulate 11 kilometers of error per day. Your ability to navigate to a restaurant on your phone depends on time travel being real and on engineers compensating for it. The muons produced by cosmic rays hitting Earth's upper atmosphere are time travelers. These particles have a half-life of about 2.2 microseconds. Traveling at nearly the speed of light from an altitude of about 15 kilometers, they should decay long before reaching the ground. But they do reach the ground in enormous numbers because time dilation stretches their brief lives long enough to make the journey. Every muon that hits a detector on Earth's surface is experimental proof that time is not universal. I think the reason people struggle with time travel is not that the physics is too difficult. The equations are simpler than most people expect. The struggle is emotional. Accepting that time is personal means accepting that the present moment, this moment, right now, is not universal. Your now and my now are not the same now. They are separated by a time difference that depends on our relative velocities and gravitational environments. There is no cosmic clock that says what time it really is. There is just your time and my time, and they are both right, and they disagree. That is the actual revolution of relativity. Not that time travel is possible, although it is, but that time itself is not what we thought it was. It is not a river that everyone floats on together. It is more like a landscape, and each of us walks through it on a slightly different path, at a slightly different speed, arriving at the future at slightly different times. I have been making this series about the universe's most extreme phenomena, the death of the sun, the inside of a black hole, the end of the universe. And people sometimes ask me which topic disturbs me the most. It is this one. Not because time travel is dangerous, although a functioning backward time machine would arguably be the most dangerous object ever created. It disturbs me because it means the fabric of experience itself, the feeling that right now exists, that the present is real and shared, is an approximation, a useful one, a necessary one for daily life. but not a fundamental truth. The universe does not have a present tense. It only has geometry. And if that does not keep you up at night, I am not sure you have fully understood it. Next time, we confront the greatest silence in the cosmos. There are 2 trillion galaxies in the observable universe, hundreds of billions of stars in each one. The probability that Earth is the only planet with life seems absurdly small. And yet, silence. No signals, no visitors, no evidence of anyone, anywhere, ever. The numbers say the universe should be teeming with civilizations. The evidence says it is empty. Something does not add up. And the possible answers are the most terrifying ideas in all of science. That is the Fermi paradox, and it might be about us.